Oh, it's kind of bright. I'm going to dim the lights over here. Okay. So the purpose of where we're at right now, we're just reviewing for the final. So I've gone through, looked at the final, and looked at some concepts. And I mean, I know this stuff is all the way from the beginning, but it's good to review this. Hey, it's free study time for you guys, huh? So, and you get subject experts right here. You can help, who can help out. So, and this is the Emporium model. So, meaning I do some problems, and then there's a very similar one that you solve. So then you can see the procedure, and then you can apply the procedure to the next problem. Okay, so determine the number of protons and electrons of each atom, or ion. So, let's see here. So, number of protons, number of protons, number of electrons. So, Ni plus 2. And to do this, you look at the periodic table. So, and nickel is right here. It's the element number 28. So 28, number 28 means 28 protons. Okay, didn't break. Oh. And I am recording this because students complained that they couldn't watch. So I'm recording it. So from the periodic table, nickel is element number 28, 28 protons. And the plus 2, that means that there's 2 electrons missing, so there are 26 electrons from that. So questions with that? Okay, sulfur minus 2. I can just look at my periodic table. I want to switch back and forth. Sulfur is element number 16. So number of protons, number 16, that's a negative ion. Negative ions means extra electrons. So the 2 extra electrons, we now have 18 electrons for this ion. So, are you having a hard time seeing that? Okay. So you close one eye, or you just wink at the screen?
I see better.
Oh, I see. Sorry, I should stop teasing my students. I'm from a big family. When teasing is a sign of affection. Or so I tell myself. So bromine has 35. So bromine just has plain old 35, and that's just the atomic number. And minus 1 means an extra electron, so 36 electrons. And chromium plus 3, chromium has 24 protons. And plus 3 means it's missing 3, so 21 electrons. So, questions with this one? All right. So I guess now you guys work on 58. And you probably don't have a periodic table. I'll go ahead and write down the protons. Actually, why don't you tell me? So. I know, I like to put the positive sign first. Okay, so we're looking at aluminum. So can you find aluminum, first of all, in the periodic table? So what number is it? How many protons are there? 13, yeah. So you get that, it's the top number. Sorry if I'm being overly exact, but 13 in selenium, 34, gallium, 31, is that? And strontium is 38. So I'm just gonna come around and make sure you are getting this. Oh yeah, I think so. Ah, more people. All right. So we're just going through problems.
Okay.
So just studying for the test. So that's going to be 10, 36, 28, 36. So any questions with this one? Okay. So give each compound an appropriate name. So I am going to give you something on the test. I'm going to give you this. So you're going to be provided this information. And there are 3 questions that deal with naming on the test. So give it the appropriate name. So A is tin to oxide, like that. And I know that O2, O, general oxygen tends to be -2. So I know that because here's oxygen there, and it is 2 over from neon. So oxygen tends to be -2. So I know that. I hate that. So it forces tin to be +2. And then you write the tin tends to be 2 or 4. So write in tin to oxide, and B, sulfur is just underneath oxygen and tends to be -2. So, and looking at S3, so sulfur being -2, that means chromium is going to be +6. I'm sorry, +3. Sorry. 2 of them is. So it's the overall balance at the charge, lowest common. So if for the S3, that's going to be -6, and then you have to take this 6. It's going to be +6, and divided by 2, you get the +3. So this is going to be chromium 3 sulfide. Where you write the full name of the metal, and then write the charge if it's not an alkali or alkaline earth, and then write the root word of the nonmetal plus IDE. And for C, rubidium is an alkali, so you just write out rubidium, and then just iodide. Just plain old, because that's an alkali metal. And same thing with D, this is barium bromide. So bromine, barium, bromine, and bromide. So, questions with how to do this? Okay. So, all right. So I guess I should probably be easiest if I just went to the chart. I know we had FeCl3, PbI4, the other ones? BAS and SRB. Was the last one's pronounced in? Oh, shoot. SRBR2? Was that the last one? Okay. Yeah, I'll write it bigger. Okay. So work on those names, and I'll come around. Is this too? In this one here, focus on the left side. You see? I guess you can see that. So. Actually, I'm going to do all the way back. I'm going to grab the table. Chlorine here is it's an epsilon charge, so it's going to have an electron there. So then they iron be a +3. Yeah, that's right. I know. What's it?
There are some that don't. The silver only forms +1, zinc only forms +2. But I mean, it's so for this one, iron is not low. You have trouble with the last one? It's broken. You don't need to put it there to
All right, looks like everyone got it. Any questions? Okay. Calculate the number of atoms in each sample. So, 87A, so 5.18 grams of phosphorus times mole phosphorus over 30.97 grams phosphorus times 6.02 times 10 to the 23rd atoms phosphorus over mole phosphorus, and put this in your calculator. Okay. 30.7 times 6.02. And this is 1.01 times 10 to the 23rd. So, and I'll do one more. That's an A. B. 2.26 grams of mercury. Mole mercury over 200.59. 0.02 times 10 to the 23rd. one. And I will take a photo of this. Okay, so you probably don't have a periodic table in front of you, so I'm just going to go ahead. Chromium is 52. And sulfur is 32.06. All right. Try it out. Oh, I should also mention that the last lab for every lab period, so mine is on Monday. That's next week. Any lab period, so mine, Dr. Fisher's or Dr. Tibbetts, it's open. Anyone can come and there'll be review sessions. Well, at least not necessarily review sessions. Come if you need questions answered, like if you want to have, if you want to work, like if you need help with something. You want to wait 7:30? Okay. Not yet. So before 6 times by 3rd?
I got 47. I used 32.
Okay. Yeah. Whatever. Close enough.
Is that right?
So, that's right. Oh, you're doing the. Okay, that's right. Okay. Oh, I was thinking that one was out. Okay. Excuse me. Yeah, you're fine. Sorry, it tripped me out for some reason. I need a beer. Rick. Chocolate? No, I left it all in my office. There's chocolate breakfast today. This is, okay. Yep, you got it. Alright, good. everyone's remembering, which is good. Now you don't have to cram at the end. All right. Does anybody have any questions with that? So lead ions can be precipitated in the solution with potassium chloride. According to the reaction, lead plus 2 ions plus 2 KCl makes lead 2 chloride plus 2 potassium aqueous. When 28.5 grams of KCl is added to a solution containing 25.7 grams lead ion, a lead precipitate forms. The precipitate is filtered and dried out to find a mass of 29.4 grams. Determine the limiting reagent, theoretical yield, and percent yield. Okay, so we have to do the equation twice. So 28.5 grams KCl, and then so look at a periodic table. Potassium is 39.1, chlorine is 35.45. So what is that? That is going to be, so mole KCl, and that's, let's see, it's going to be 70, I should just do 74.55. Is that right? That looks right, yep. Times mole PbCl2 to 2 moles KCl times, let's see here, lead is 207.2, 207.2, and then plus 35.45 times 2, so that's 70.9. So that'd be 288.1 grams PbCl2 per mole PbCl2. Am I doing that right? I'm just doing it in my head. I should probably use a calculator. 207.2 plus 70.9, 278, okay. Okay, and if we run this through, out of space. So 28.5 divided by 74.55 divided by 2 times 278.1. I'm getting 53. 83.2 grams PbCl2. Okay, so I gotta do it for the lead ion now. And 25.7 grams lead plus 2. Mole lead plus 2. The plus 2 ion is pretty much the same mass as the lead itself. And lead itself is 207.2 grams Pb plus 2. Mole Pb plus 2. Cl2 to Pb plus 2. 78.1 grams PbCl2. PbCl2. All right. So 25.7 divided by 207.2 times 278. And this is 34.5 grams PbCl2. So from that, we pick the lowest one. This one is the limiting reagent because 34 is smaller than 53. And then determine the limiting reagent, theoretical yield, the percent yield. So percent yield is actual over theory. Jeez. Actual over the theoretical times 100% equals actual 29.4 divided by 4.5 times 100. I'm getting 85.2%. And there is the percent yield. Like so. Okay, recap with this one. We have this reaction here. We're given the amount of reactants. We have 28.5 grams potassium chloride and 25.7 grams lead plus 2 ions. And we react it and we get a product that's 29.4 grams. As for the limiting reagent, theoretical yield, and percent yield. So we have to figure out what the limiting reagent is first. And you do that by calculating the percent yield, or the theoretical yield for both. So the theoretical yield, starting with 28.5 grams potassium chloride. So got to turn this into moles. So molecular weight potassium chloride. And then looking at the balanced chemical equation, there's a 1 to 2 molar ratio between potassium chloride reactant and lead chloride product. And then this is the molecular weight of lead 2 chloride. And then from this way, we would get 53.2 grams of lead chloride. Same thing with the lead ion. The lead ion is going to be the same mass as lead. The 2 electrons are very, very light. They're about 1/2000th the mass of a proton. So it does not even come into account with this. So 2 of them, so it'll be a 1/1000th the mass of a proton. So it'll just decrease this number by about 1/1000th. And there's not even enough significant figures on here for that. So but don't worry, it's not going to be that specific on the final. But all right, so convert this to moles ions, and it's moles lead chloride to moles lead, and then molecular weight of lead chloride. This one yields 34.5 grams of lead chloride. So this is the limiting reagent because it's lower. And this is also the theoretical yield. So this is what we should get using this reaction. We actually get 29.4, so we take the actual yield over the theoretical yield, and we get a percent yield of 85%. So, questions with this? Yes? Yeah. I guess reactant's a better word, but reagent, I'm just thinking in the lab when you pick it up in the stock room, they call them reagents. It's also reagent grade. Like if you buy salt from Fisher, it's going to be reagent grade versus if you get salt from Long's. So, other questions? Okay. All right. Now it is your turn. You know what would be easier if we just made everything grams? rid of the kilo.
Would we be given a problem like this on the final? That we have to convert it from kilograms to grams?
No. And you're also not going to get a problem this hard. You'll be given a problem that'll be like a percent yield problem, but it'll already give you the information. You'll be given a limiting reagent problem that's usually just goes to moles. These are designed to be quickly done. It can be done in less than 2 minutes. So, but this is a big long problem that covers many different topics. Like this is helping you study for like 3 or 4 questions, or even more because you're also converting between mass and moles. I guess I should give you the masses. Well, this ammonia, this is 17 grams per mole. This is carbon dioxide's 44. Water is 18. And what the heck is that? Oh, it's urea. Okay. This is going to be 12 plus 4 plus 28 plus 16. This is 60. Is anyone getting stuck? Just need your time. It'll be the same.
Okay. Yep, you got it. Yep. Yep, you got it.
Oh yeah, I just rounded it up. It's 69.96. 36. Can I guess four six? I guess it'd be 69.96. There are 4 sig figs. I'll be exact.
It's 60. Oh, I see. This is beer. This is grams for Maltese. 60 grams per 60 grams. Is that it? Yeah.
Yeah, you got it. And that's actually the minimum agent.
You don't need that half gram. Yeah, because it's a 1-to-1 ratio. So I'm an annoying little brother. I am an annoying little brother, actually. That's my brother. Yep. You actually use this is the take that divided by. So it's only 168 what it obtains. Your actual yield is 168.4. But yeah, that was 168.4 over. Yeah. Looks like you get right. Okay, so moving on, molarity of each. So lithium is 7, and this is 35.45. So this is going to be. Oh, you don't need to worry about that. Oh, geez, the molarity. Okay, sorry. This one, I'll do A and B. I'll let you do work on C. So molarity is just moles per liter. So A is 3.25 mole LICL divided by 2.78 liters, and just straighten your calculator. Divided by 2.78, and this is 1.17 molar LICL. And so for B, so for B, 28.33 grams glucose times mole glucose. Glucose is 180 grams per mole. And then just divided by 1.28 liters. So 28.33 divided by 1.28, 0.123 moles glucose per liter equals 0.123 molar glucose. So you see here where I'm going for the units being moles whatever over liters. So that's the point there. So why don't you work on number C. And sodium's 23, chlorine 35.45. So NaCl is 58.45 grams per mole. Oh, it's funny I can forget all this stuff, you know? Or maybe you're just remembering it right outright. This always takes so much brain power for me to do this, actually. So I have to concentrate. I get tired. I get tired doing this stuff. And this isn't really the fun part of chemistry either. It's like the boring, it's in my opinion, I don't know. I mean, some people may love stoichiometry. So you do it by units. Start with the grams, where's the moles here? You're looking for moles
point that.
Yeah.
No, I had changed it.
Okay, that's fine. Yeah, I mean, that's what the problem is. Okay, there's a problem like this in the final, and from my lab section, students are having a hard time with this one. So, the molarity of an ion, so I do want to go through each of them. So, so if you look at the nitrate, you're looking at the nitrate only. And for part A, it's just straight across. So this one, it's a 1-to-1 ratio. It's going to be 0.15 molar. B, there's a 2 there, so it's going to be, the formal way to write it out would be, so 0.15 molar calcium NO3 2 times 2. Actually, okay, I'll do this. 2 mole NO3 minus per this will be 0.3 So the capital M, molar, means moles per liter. So for this one, you can do it one of 2 ways. You can look at the 2 and multiply by 2, and then be done with it. Or you can do it formally. The 0.15 molar calcium nitrate means 0.15 moles calcium nitrate per liter. And from this relationship, there's 2 moles of nitrate for every 1 mole of calcium nitrate. And then multiplying across gives you 0.3 moles nitrate per liter, or 0.3 molar nitrate. Does that make sense? And then for C, it's just 0.15 times 3, which is 0.45. I guess if the 3 6 is 0.450. So next one is just the 3 there, it's just times 3. All right, so you guys can work on 56.
Yeah, yeah.
Okay, there's a question like this on the final, and it's an easy question. You do not want to get this one wrong. Right? Get the hard ones wrong and the easy ones right. Don't get the hard ones right and the easy ones wrong. Or actually, you should get them all right. What am I saying? Well, nothing makes me more angry than like, I've done that in 2 seconds. Oh, you're doing the formal one. Okay, it always works. There's 1 mole Cl to 1 mole NaCl. You want to do it that way. So the 0.2 moles NaCl.
Yeah.
And you see where you get the 2-to-1 ratio. Got it.
Question.
Yes.
Why would you want to know the molarity of the
The other ion could react with something. Like if you have lead in the water, lead chloride gets out, so something like that. Yeah. Or also aluminum corrodes in chlorine, so it depends on how much chlorine is in something. How much will corrode. Okay, so for these ones, I'll use the equation M1V1 equals N2V2, or you could, some places listed as C1 C2. So with M or C, whichever one you prefer. So M1 is 1.1 molar glucose. Volume 1 is 123 milliliters, equals our unknown molar glucose. It's an M. And then 500 milliliters. So what do? Divide both sides by 500, 1.1 times 123
divided by 500 equals our unknown molarity of glucose, which is 1.1 times 123 divided by 500. Basic things. 0.271 molar glucose. Okay. So try it for 62. Oh, there's two sig things. So what's that? Yeah, but it's just, well, two sig things, but whatever. Two sig things, but do you guys want me to send you the given information? Yeah, okay, I'll send it out. So you know what you get. All right. So for these ones here, you will be given a solubility chart. So I guess what I could do where is it? Actually, I guess what I could do is I went too far. All right. Sorry, as I look for the chart. I went too far there. Come on, chart. Okay. So you can see this is what I do before class. Okay. So if no, so complete, look to see if there's a reaction. So lithium is going to bind with sulfur. Lithium is an alkali, is always soluble. That's not going to be a precipitate. Barium is going to bind with iodine. These tend to be soluble. Barium is not an exception. So because of this, this one is no reaction. Okay. So potassium, the positive ion's going to go with sulfur or sulfide negative ion. Sulfides are down here. These tend to be insoluble with the exception of alkalis. So that one's fine. And then, so calcium bonding with chlorine then. So calcium and the calcium sulfide is going to bind to the Cl minus. So chlorides tend to be soluble, and calcium is not one of them. So that one is also no reaction. So chromium going to bind with the carbonate. Carbonate is down here. Carbonate tends to be insoluble with the exception of the alkali and ammonium. Chromium is not on this list. So Cr is not on this. So that means that this will form. So chromium CO3 solid plus 2NaBr aqueous will form. And then the last one, sodium and chlorine, so all sodium ions are soluble. Then FeOH, hydroxides tend to be insoluble. So from this, iron hydroxide will form. And then we have NaCl. So put a 3 here and a 3 here, and it is balanced. So, questions with how to do this one? Did you see the logic with the chart? All right. Maybe I should make the chart smaller. Do I want to make a search? I guess I can just do it this way. There we go. Do we have any carbonates or phosphates? No. Okay. There we go.
it's just one A. Two A. Same thing with the ammonium. It's two acids and two ammonium.
Sorry, that's the class is over alarm. So you guys are. I'm just gonna go around and make sure everyone gets it, but class is officially over and you are free to go.
Oh yeah, it's just the Hg2 is just two mercuries joining those two oxygens. So you have two COs. Okay, and so when you have ammonium chloride here, it's the two of them. They're plus or minus one. So there's just two of them. Ammonium dichlorine. So it's just two of these pairs. This is because yeah, it's the polyton line. It's also it doesn't exist as H4,2CO2. It certainly exists as an H4 and then Cl. Did you read this chart from the other day? Oh, there's okay. Yeah. I hope so. Doing the same? We don't know, there could be no reaction. This one here, you look at silver and chlorine. Chlorine tends to be soluble with silver. Where? As long as you understand it 2 weeks from today, and do it then.